Hello and welcome back to Blender for Biochemists. Today I'll be showing off the DNA nodes that are now part of molecular nodes. DNA nodes lets you extract DNA from a structure or procedurally generate your own DNA through curves and move it around, edit it, unwind it as you please. So we're going to get in how to use it. I have shown tutorials before on how to make your own. This is a bit more complex and a bit more production ready, and so I'm going to walk you through how inside of molecular nodes you can add DNA and use it in your scene. So importantly, I'm on molecular nodes version 0.10.3, so I added them in 0.10, so you need to be above 0.10 to have access to these nodes, and I recommend getting the latest version because then you'll have some nodes that I've fixed bugs inside of. So I'm going to, you don't have to do this, but I'm going to just download one DNA to begin with, because this is some example DNA. So if we go into our geometry nodes, go into render and cycles, so we've got some DNA here, but what we are limited by is, well, our ability to sort of generate longer strands of DNA. And so what we want to try and do is, like I've shown in my tutorials before, you can have a curve, and from the curve you can generate DNA rather than basing it purely off a PDB structure. So in the viewport, if we go Shift A and add a curve, Bezier, we can see it's down there. And if I press Tab into edit mode, I can sort of move these around as I wish. Tab back out. And so while having this curve selected, you can click New, and OK, so we have a geometry node set up on our curve. Now, in molecular nodes, you'll find a new category called DNA, and so a whole bunch of different nodes. Now, I'll walk you through which ones you're going to need to do. So if you see up the top here, helix double-stranded, so if we put that on, we'll see, we can't actually see anything. And that's because there aren't any DNA instances plugged in yet. If we look at, say, the curve, there is a curve being generated, so two different curves, both of the helix, but we don't have any instances yet. So from DNA, we need our base primitives, and then we need to style it. So it is sort of a little bit convoluted, but allows for more customization, and it's more modular this way, so it's easier to bug fix and easy to extend. So I'm going to go DNA base primitives and plunk that down. You'll see it's added a whole bunch of collections with all sorts of information and selected mole DNA bases. Now these you can just turn off straight away. I haven't got a neater way to import them yet, unfortunately. It's strangely quite difficult. I'll leave that DNA on there. And so we've got our bases, and well, if we plug this in, again, nothing's happening. Now this is because this is called DNA atoms, and this expects DNA instances. So we need to style it and convert them to instances. And that's done by DNA style nodes. Now don't use these styling nodes, because some more things need to be done under the hood to convert it into a format that you can actually use in the DNA, and so you need to use these specific DNA nodes. So let's just go with atoms and put that on there. Now we're starting to see it. So we've got our primitives, which is just our DNA bases, and we can choose our colors here if we would like. We add a style, so just the atoms, and then the output of that is DNA instances, and then that goes into here. And just like that, I'm just going to delete that default cube. We have some DNA that if I go into edit mode and I press E, you can now procedurally generate on the fly. So S to scale, E, and so we're making our DNA. And so you can see, well, this is all colored just by base. This is all colored just by base. And if we go DNA base color, you can color that specifically per the base and the backbone. And so if you wanted to maintain the base colors, you can plug that in, and the bases themselves will be colored, and then the backbone will be whatever color you choose. Or you could go DNA color element, and it will color by the element. If you wanted the carbons to be the base color, you can plug that in, and we have all the element colors and also the carbons are base colored. This is way too noisy and I wouldn't recommend it, but if we cut that out and we now use a little bit lighter color, you're basically getting the same thing as this DNA here, but this is procedurally generated. This is procedurally generated, and so we can edit it and move it around. Now, I'll show you. Now I'll plug that in there, plug that in there. Now this is using the atoms that are only visible in cycles. Let's actually add a sun just so we can see properly what we're doing. But what I want to do is use the EV atoms. So this will make atoms that are visible in EV. Now these atoms will, when you start getting a lot of DNA, it starts getting really laggy. So you can see already the viewport's a bit laggy compared to just the point cloud. So I would try and steer clear of them, but they will be visible in EV. If we go DNA, and my favorite is the surface. And so generates a surface, and you can adjust the sort of surface to get a lower or a higher res. You can go low res if it's going to be far off in a scene, and you can improve the optimization of it. And there's other sort of settings there. I'll bring that down. And so those are the styling nodes. Well, actually I'll show you one more, which is the DNA ball and stick. Now you'll see if you choose to use ball and stick, and let's actually go element, you'll see that they're not actually bonded at all. Each base is treated at its own specific instance. This is for optimization inside of Blender, etc. And I'm not actually going through and calculating bonds for this DNA, and so you'll see up close that this doesn't actually look very good. And if you get some extreme sort of movement, then things don't really work out. Now the DNA would never actually do this, and so that's why this is all looking funny. I prefer just the surface representation or just the atoms. So if we go back to our atoms, that way you just increase the radius, and you don't really notice that they're not bonded how they should be. And it all sort of, because ultimately, if you want to get that sort of granular detail, really you should be looking at an atomic structure and not at a procedurally generated version. This is the styling. The node itself for DNA, you can rotate it, that will rotate the whole thing. You can rotate the second strand independent. A value of 1 will be what it basically should be. You can unwind it, so a value of 0. Let's actually bring that down to about there. A value of 0 will unwind the DNA completely, and a value of 1 will be as it should be. Unzip will move the bases either towards each other or apart. And if I color these by their color, and we change the seed, this will change the random bases that are chosen. Now your greens will be your A's with your T's, your G's with your C's always, and so your base pairing will be correct, but currently it's just a completely randomly generated sequence. I do have plans on how to import a sequence, but again, if you're just using it for set dressing, the actual sequence really isn't that important when viewed from far away. And so those are the options there. Unwind and unzip are fields, and they can be done locally. So what do I mean by that? If I add animation object effect, and then we create an empty, and I select that empty. Then I can use the effect to unwind. So 1 to 0 should be. Now we've got this empty. Now if I scale it, wherever this empty is close to, it will procedurally unwind the DNA. Now you can combine that also with the unzip. And actually the unzip will want to map. So if we go map range, we go from 1 to 0, 1 to 3, and then we go unzip. Now it's a bit extreme, bring that back down to about there. Now not only does it unwind, but it also unzips the DNA as it goes along. And so that's an example of that. We've got our DNA, we're creating it. You can also then use just each set of bases if you want just one strand, either one strand or the other, or you also have access to the curves. And then the points along these curves, you have access to the rotations that are required to instance and properly rotate those bases. Now, along with the styles, you can also create your own DNA base. And so if we go DNA base custom, and we use, say, just a cylinder, so if we go mesh primitive cylinder, plug that in, what we'll need to do is make it a bit smaller. We're using our own base. Now currently this is just repeating base A and changing the color. If I turn that off, then you'll need to have a different mesh for each of the bases and it will color them all. But because I'm just going to use the same mesh in all of them, I can leave that on. And if you have a specific material on the mesh you're piping in that you would like to maintain, then you can turn that off and it will maintain and it will ignore all of this. But we'll leave that on. So we've got our cylinders, or if I wanted to have a Suzanne, add a monkey, and we go our Bezier curve, drag our Suzanne on, and we transform. Let's scale that down a bit. And now we've got lots of monkeys as our DNA bases. And you can adjust that. Now we'll use it, DNA monkeys as DNA bases. So that's some examples of how we can quickly create procedural DNA with only a handful of nodes. So this will take a curve. If we want to have multiple curves, we can add a new curve. Let's go curve Bezier. Now this keeps changing off whenever I select something else. So I'm going to select this and pin it, and that will keep that geometry nodes node tree highlighted for this Bezier curve. But this second one, what I want, alright, so we've got another curve that's sitting here. And what I would like to do is join these two curves together. So what I can do is DNA curve join. So this takes two separate DNA curves and will output a joined curve. So if I plug one in, and then I plug the second one in, and then if I just look at this, you can see, oh, nothing's actually happened. And we can, oh, actually I'll need to turn that to relative. Now you can see what it's gone and done is it's joined from that end. I want it to join from this end, so I can reverse that and it will reverse this curve. And now we're all joined up. I'll turn down that cutoff. Now what this cutoff is how far away it is until it joins. So if I take this and move it closer, it'll join up like that. And so what does that look like if we pipe that into our DNA? Now I grab this one, and our DNA joins up. And so you can have this be part of your animation if you want to do some sort of enzyme that breaks apart what joins your DNA. Then you can have your curve. Now this sort of comes together from far apart and sort of snaps. You can turn that down to make it so it happens only a bit closer, but that should happen there. So that's just procedurally generated DNA. I'm also going to demonstrate how we can do it from a DNA structure. So 3AV2 is a histone, and if we go back into Blender and click download, we'll wait a few seconds, and now we've got our structure inside of molecular nodes. Now, to be able to join this DNA up with this structure, I want to be able to extract the curve that the DNA is part of. So if I get this one, and so I've had to untick that to get the node tree for this protein, I can go DNA curve extract, and this extracts from the structural file itself the actual curve that makes up the backbone. You can add some sort of smoothing to smooth it out. And you can also use this to extend the ends a bit if you want to extend it. Now it will extend just in a straight line. Whether or not that's helpful to you, you can just turn all the way to 0 if you'd like. And you can adjust this smoothing to get a smoother sort of curve. But now we can have, okay, DNA curve. And so I've got the curve from this structure. And so I can then go DNA, get my primitives, add my style, and then also add base color. And if I want, I can just extend the ends and it will continue out the DNA. And if we also add ribbon and join those two up, we've now, I'm just gonna delete that curve, actually leave that curve, but keep this. And so just like that, we've got our DNA with our cartoon structure. Let's change that up a bit. And we can adjust the DNA if we would like. We can add on to it. So if we go DNA curve join, and then we can add a new curve and drag that in here, relative, plug that in. And if we get this curve and plug that in and adjust our cutoff, there we go. And now we've extracted the DNA from this structure and joined it up with now totally procedural. And so this, as we move this along, that'll move the DNA as well in there, or if we rotate it, it rotates the whole thing, etc. And so that's a, let's just do a quick render. Get rid of that DNA. Get rid of that light. Get our sun. and then have our camera depth of field. And just like that. Cool. That's a quick introduction on how to use the new DNA nodes inside of molecular nodes to procedurally create DNA and also extract DNA from a structure to then use procedurally as well. So thanks again for everyone for the support, for the kind words. Please do keep tweeting at me with your creations. I really appreciate the kind words, and I really appreciate the coffee especially. So thank you to those who have purchased me a few coffees. And with that, please do keep sharing, please do like, and please do subscribe. Thanks everyone, and I'll see you in the next tutorial.